Okay, section 1.4b, solving absolute value equations. And this is a really pretty simple, you just have to understand the concept and what to do, but the math is very easy. So the first question is absolute value. I know you've had this back in high school. Absolute value, the technical definition is the distance something is from zero. What it really means in practical value is that when we are interested in the magnitude of a number but not the sign. In other words, we want to, it's going to strip off any negative signs. We only want to know what the number is regardless of the sign. So just a kind of an example of how this would be used. Let's say that you got stuck in your car and you're at mile marker 50, right? And you got two of your buddies are in different cars, and you go and you phone them and go, hey, I'm stuck at mile marker 50. Whichever one of you is closer, come and get me, right? So Joe, he's at mile marker 55, and so the math would be, okay, if X is the distance Joe is, then to figure out how far Joe is, you'd say, well, I'm 55, I'll subtract the distance that you are, would give me the distance of 5. So Joe says, well, I'm 5 miles away. Mike, he's at mile marker 45, and if you use the same math, well, 45 minus 50 mathematically produces what? A negative 5, okay? Now, obviously, Mike is the same distance from as Joe is. They're both 5 miles apart, but yet the math problem produced a positive and a negative. We don't care about the negative. It's irrelevant to the problem. The question is how far away, not which direction. And so the way that this gets solved is you throw an absolute value around the math problem, and then that'll strip off the negative. So in this problem above, if we used absolute value, well, 55 minus 50 is 5. If I apply the absolute value of 5, I do get a 5. If I do 45 minus 50, the absolute value, well, inside the absolute value, I get an answer of negative 5. But absolute value, when you apply it, takes off the negative sign, so it too would equal 5. So here, mathematically, we go, yeah, these are exactly the same distance. And there's a lot of applications, tolerances in engineering and manufacturing. It could be a little bit bigger, a little bit smaller. You don't care whether it's bigger or smaller. It just has to be within a certain tolerance, right? So you would apply the absolute value to those problems. Okay. Now notice that the x up here, there's two answers that produce the correct answer. Let's say we wanted it to equal 5. 55 would produce a 5 in this problem. 45 would produce a 5. So the key here is absolute values. The x will have two values that will produce the same answer. So to get two answers, you have to have two equations. And so this is the part you have to remember. So, taking this from the class notes, if you take the absolute value of x minus 4 is equal to 7, then one of two things can be true. The value inside this absolute value, the x minus 4, could ultimately be equal to a 7. But we know that this could also be equal to a negative 7 because the absolute value will strip off that negative sign and make it equal to 7. So we know that if what's inside can be a 7 or a negative 7, that is going to be our two equations. We set the inside equal to the 7, but we set the inside of the absolute value also equal to a negative 7, and we just solve each one. And again, these are going to be very simple equations. Here I add 4 to both sides, and so I'm going to get x is equal to 11. Here, when I add 4 to this side, minus 7 plus 4 is a negative 3. Okay, so here are my two different answers that will produce a correct answer when the absolute value gets applied. You can check it. I can put 11 minus 4 in absolute value. That's going to be a positive 7. And when you apply the absolute value, you get 7 is equal to 7. That's correct. Negative 3 minus 4, that produces in the absolute value a negative 7. But when I apply the absolute value, I end up getting 7 is equal to 7. Okay, so to get two solutions, two equations. So a couple more examples from the class notes. Here's the absolute value. of 2x plus 1 is equal to 5. Okay, so what do? I set the inside equal to 5. I set the inside equal to a negative 5. And then solve each. Okay, subtract 1, divide by 2, I get x is equal to 2. Subtract 1, divide by 2, I get x is equal to negative 3. So there's my two answers that will produce a 5 when the absolute value gets applied. You can check it. Okay, so the steps are real simple. What we haven't done, and I'll show you an example in a minute, the first thing you need to do, though, is you have to isolate the absolute value to one side. Just like you try to isolate a variable to one side, you want to isolate the absolute value. So any numbers outside of the absolute value need to be removed like any equation, okay? And then once you have isolated it, you write the two equations as we have done above, setting what's inside the absolute value to the plus of the right side and the negative of the right side. Solve both of those equations. They'll be simple. And then I'll talk about this in a minute, but you want to make sure that it can be a valid answer. Check for extraneous solutions. What an absolute value cannot ever be is equal to a negative number. So if at any point you have just the absolute value equal to a negative number, you can stop. This cannot ever be true, because when you apply absolute value to whatever is in the absolute value, it always produces a positive. This is impossible. So you just got to be on the lookout when you have a situation of an absolute value equal a negative number. But again, it's when the absolute value is isolated. Okay, so let's take a look at a couple more from the class notes that we would have gone over. So here's a case where the absolute value is not isolated on one side. I got to get rid of this 4 just like I would any equation. This is no different than thinking of 2x plus 4 is equal to 10. What would I do first? Well, I would if I wanted to isolate this x, I would get rid of the plus 4 first by subtracting it. So I'll do that. I subtract 4 from both sides, gets rid of it on the left. 10 minus 4 is 6. Now the absolute value is isolated, so then I take the inside of the absolute value, set it equal to the 6. Take the inside of the absolute value, set it equal to the opposite, or the negative. Solve each of those. I'm not going to go through it. It's just, you're going to get an answer of 8/3 and negative 4/3. Okay? Example of one that you would stop at this point. Once you have gotten it down to absolute value by itself on one side, so if there were other things on this side of the absolute value, you get rid of them first, and if you ended up with something that looks like this, you stop, because an absolute value can never equal a negative number. Okay? So go ahead to your worksheet. You have some absolute value problems. I'll record the solutions and post those.